Hello there, it's Jay here from Jay's Vintage Junk, and today we're back on with the old C16 and Plus4 project. And I've dug the first of the boards out, and I thought what we'd do in this video is have an assess of the board. Basically what I'm going to do, I'm going to take it out of the case, have a visual inspection of it, because we don't want another little mishap like we had with that Sega Master System. So we'll just make sure, because it does look like it is a bit bashed about. I mean, there's pins bent here, there's components bashed over and what have you, so we'll have a good visual inspection of the board. We'll have a quick look at the power supply. We'll then actually power the board up without the main ICs installed, and we'll actually just do some basic checks. I want to make sure that there's that the 7805's working okay, the fuse is alright, the switch works alright, there was no erroneous voltages on any of these two sockets here that may indicate there is a fault somewhere. When I'm happy with that, we might actually see put a known good TED and CPU in this board and actually see what it does. So yeah, I think that's what we're going to do. So without further ado, let's bring the old PSU in. Now, this is a genuine C16 PSU. I did have a look online, and I can confirm a specky PSU would replace it no problem. It is centre pin ground, same as the ZX Spectrum. ZX Spectrum PSU puts out what, 9 volts at about 900 milliamps, something like that, unregulated. This is meant to put out 9.5 volts at 800 milliamps unregulated, so it's close enough. Like I say, if you didn't have the correct power supply, you could indeed use a specky supply if you've got one. I think the connector is pretty much the same. I think it would fit. Let's plug it in and switch on. I'll get the old meter in shot, and we'll just make sure it is actually wired the right way around, and it is indeed working. I can't see why it shouldn't. So we've put the meter probe in the centre, so it should be centre negative. And it's giving us, remember this is an offload voltage, but it's giving us what, about 17 volts there. But like I said, that is offload. That should come right down when we actually put power to the board. But it's giving voltage out, it's giving DC voltage out, and it's the correct polarity, so that should be okay. Like I said, it is unregulated, that supply, so it will drift quite high with no load on it. Right, I will practice what I was preaching in my previous video, and I will put my anti-static wrist strap on. Especially seeing we are going to be handling that CPU and TED hopefully later on in this video, and there's no way I'll be touching them off a board without anti-static on. And I'll pick my screwdriver up that I've dropped. Let's get this board out of the case. But where's my little pot? Right, I've got an empty pot there, I can put the screws in. I think that should be the last one. Let's see, this board will come out. There we go. That's nice and manky. I'll put them for a bit of a bath, I think. Oh, excuse me. Dear me. Right, so here's the board. Actually, it doesn't look in bad condition. There's a little bit of corrosion on the back of it there. That's probably from storage. Very light amount of corrosion on the modulator there, but I'm not really that bothered about that. Let's have a look on. Ooh, that looks nasty. It's just the locking compound when they screwed that screw in there, but as you can see, they're a little bit over enthusiastic with it, and it's dripped right down the board. So we'll clean that up. There's an interesting little bodge wire there. I don't know if you can spot that on the video. You can see just near my thumbnail there. We've got a little wire just going between them two pins there, so that'll need looking at, see what that's about. It's on that little trimmer there. Apart from that, I can't see anything else. Got A30 wrote on it, I don't know what that's to do with. Apart from that, the bottom of the board actually doesn't look so bad. We'll have to look at that little bodge there though. It's as though someone's linked out that little trimmer. Can't see any bad solder joints or anything. It does look like possibly either the flux hasn't been cleaned off originally, or someone's... No, because these are all nice and clean. It looks like someone's resoldered all the sockets at some point in the past. If you look here, you can see all this flux residue, and it's just round everything that's basically on the edge. I think someone's been over this board before. I don't think it was me. I honestly don't think it was me. But someone's been over this board before and they've resoldered basically all the sockets, so I wonder if it's had an issue in the past. On this side there are quite a few components which are pushed over, but I can't spot anything damaged so far. We'll just have a quick walk around the board and just make sure, we'll just lift everything that's been squished out of place. And just make sure we can't spot any, it is actually a good idea just to move them slightly, because we didn't spot that one in the Master System. Not until far too long. And because it actually looked okay, it weren't until it was actually touched and moved that I realised it was broken. That transistor's had a bit of a whack. That's a bit squashed over. Let's see if we can just straighten that. That's alright. I'll probably end up replacing these electrolytic capacitors. They are of an age where there's only a few of them, and they are early 1980s. I mean, this board's what, copyright 84. Let's have a look at some. Yeah, the parts on it are all dated around 84, so it's got some age to it. These caps will definitely have to go. We will replace them out, but we won't do it immediately. We'll see if we can get the board actually working first. I believe these are just the ROMs. I'm undecided about that socket there, the empty socket. It's empty in all these boards. I did watch a video and someone said something about PLA, but I don't think it is. I think it's just a spare ROM socket for some additional ROM that could be added to these things. I may be wrong about that, so we may have to find out. We need to populate that with something, but we'll find out that anyway. Everything else, look. Oh, these caps have they are still attached, but they've had a bit of a hard life by the look of it. We'll just straighten them up. I can't say these have been particularly well stored either. They were my basically my scrap boards. So I'm sure that they will have something wrong with them. I'm pretty certain they will have at least something wrong with them. That's not looking too bad now. Everything's that keyboard connector's horrifically bent, but that won't stop us powering it up. We'll deal with that if we actually can get the thing to do anything. Right, let's put some power up it, and we'll do some voltage checks before we stick anything in them sockets there. We'll get the old tester in. We'll set that to 20 volts. Let me get a crock lead so I can actually just connect the common to ground, and then we've just got one wire we can probe around with. I think the case of the edge connector of the cartridge port here should make a good ground, so we'll go on there for the ground, like that. In fact, what we'll do is just switch the meter quickly to continuity and just confirm that. Yeah, confirm we've got a good ground there. Set that to voltage. we'll get the old power supply for it. Just get it where you can see everything. Right, there we go. That's better. There we go, that's better, isn't it? Right, let's plug that in there. Is that on the, that's in the off position. And plug that in there like that. And switch on the power. And what I'm going to do is I'm just going to measure the LM7805 here. And I'm going to measure the input on it, because I want to see whether that's dropped from that 17 volts. We should be close to like between like 10 volts, 11 volts. If it's anything higher than that, then I'll look for a different power supply before we go even further, because you really don't want more than, say, 12 volts on a 7805. It can handle more. It can handle probably about 20 volts, I think, 18 volts, something like that. But the lower you can get it, I mean, these things will regulate from about 7.5 volts down to 5 volts. So the closer you can get it to 9 volts, the better, really, on your input. So we'll go on to the input and we'll switch on, and this will at least prove whether the switch is working, and I think prove whether the fuse is okay. So let's switch on and see what we get on the meter there. And we're getting nothing. We're getting absolutely nothing there. Let's switch off again. Let's see if we get anything on this fuse. Now we're getting 17, yeah, nearly 18 volts on there. Let's try the other side of the fuse. Now we're getting 14 volts on there. But we don't seem to be getting anything on the 7805 here. Oh no, there we go. Now that is a bit high. We're getting 13... Yeah, we're getting about 13.5 volts there on the input of the 7805. I think that is a bit on the little bit on the high side, really. Let's try seeing what the output's like on it. That's way too high. Let's get that switched off straight away. So as you can see, we've got 6 volts coming out of the 7805 there, so that's no good at all. We'll try a different power supply. I'll get a specky power. Well, it's not actually a specky power supply. It's one that I've it's a modern switch mode power supply, which I've got housed in a specky case, and I've got it set up. I use it for the Spectrum and the Master System, because they're exactly the same. They use the reverse polarity on the power supplies. Let's see if I can find it. It should be around here somewhere. Where have you gone? So it's typical. Every time I tidy my workshop up, I then spend the next couple of weeks actually looking for stuff. I knew I had that lying around because I was using it with that when I was doing that Master System. So where the hell's it gone now? Just bear with me a minute, folks. I'll be back as soon as I've located this power supply. Okay, well, I couldn't find my power supply I wanted, but I did find a grey specky PSU, and that gives out 9 volts at about 2 amps, so it's absolutely fine for this this purpose. And it gives out a slightly more sensible offload voltage as well. It's still quite high, it's about 14 volts, but even so it's a lot better than it was. But unfortunately it does look like we've got a bad 7805 in this. So we connect up, and even with this new this better power supply, if I actually probe the output of the 7805 and switch on, we've got 6. I won't switch it on for very long, but we've got 6.2 volts there, and that's way too high. So the first thing we're going to do before anything else is replace that 7805. So I'll get the old soldering iron warming up. I should have really switched that on before I started this video, but hey ho. Let's get let's reconnect myself as well So we're going to be working on this thing. Let's get the power supply disconnected for now. And we'll get this 7805 off the board. Let's get that piece of metalwork off as well, because I don't like it rattling around like that. I think there's a screw missing from that, because I'm sure I didn't take a machine screw like that out. They're all plastic. Oh no, I did. So we've got that. Take the little cover shield off there. What I might do is just, while I'm out here, while that's off, I'll get the old contact cleaner. I'll just see if I can get some into this switch without dismantling it. It does seem to be working. You can dismantle these switches like you can the C64 switches, but hopefully, because it was working, I can just perhaps get a little bit of a cleaner in there. And just work the switches. I'm sure they won't have seen any cleaning action for a very long time. Right, let's see if we can get this heatsink off here. Ah, we're in luck. That seems to break free. Let's there we go. We'll make sure we keep the screw and the nut safe. And slide this old heatsink off. There's a little bit of icky old thermal grease in there, so we'll clean that off. And we'll put some new thermal grease on, and we'll put the new 7805 on here. Let's get that cleaned off. You see how important these initial checks are, really. I mean, if we just stuck a TED and a CPU on there, and we're feeding 6 volts, or just over 6 volts into what should be the 5 volt VCC line, we stand a very good chance of killing some incredibly rare chips. So that's why these checks, especially when it's something like this, where basically these are unobtainable, it's vital you do checks like this. Don't ever just get one of these, especially if it's an absolute perfect find, no one's tried switching it on, and just powering it up. Please don't. You need to remove them. You need to make sure the board's actually good first before you even try them ICs. Because imagine it's just something as simple as, I mean, how much is a 7805? About 60-70p, something like that. If you buy them one-offs, usually 2 for £1.50, including postage. I've seen them online. Imagine something that cheap killing an irreplaceable CPU or your TED chip. So yeah, let's get that off here, and we can put a new one on there. Dampen my sponge a little bit. There we go, don't need much. Hopefully this iron's man enough for this, because they are quite large components really for this tiny iron. Brilliant at the small stuff though. Well, we've got most of it. So a bit of fresh. Doesn't help that that locking compound that they used on them, that nut has leaked right over the solder connections. That's making it a bit tricky to get stuff off. And this one's struggling a bit because it's it's on the big plane there. It should go. Try adding a tiny touch more solder to it. I got most of it out. I think I'll just have to do a couple of passes on this. Let's try this, and it absolutely stinks. This, it's horrible. It's the it's like a varnish that they use to seal that locking nut, and obviously it's heating up with the soldering iron. It absolutely stinks. once we've ascertained this board is a viable repair, we'll clean all stuff like that off. But for now, I just want to see if I can actually get the board to run. Let's have a look there now. One leg's free. Let's add a little bit more fresh solder because it is horribly contaminated, that, unfortunately, with that varnish getting in there. That's better. Yeah. I'll go like that now. No, it's not quite. So one leg, that first leg is nice and free. I can feel that free. It's just these two here. You just need a little bit more work on them. See if I can get some of this. There we go. Let's try that now. That's the middle pin now. The other two pins are free. Hopefully that's got it this time. Nope, that middle pin is still holding on. Let's just try heating that middle pin and whittling the other two. See if we can get it out that way. It's just like the last little dregs holding it now. Let's try giving it another suck. Yeah, the other two are free now. It's just that middle one that's just still holding on. Try going in here. That one's out. Oh, that's broken off. That one's out. Hopefully we can get that last little bit out now. Another organ donor going down the road. Come on. There we go, that one's clear. Let's get these others clear. And we can get that nice new 7805 in there. We can take it from there. Just got this this middle one to deal with now. And there we are, we're clear. Let's just get a bit of something on there just to clean that up. Now I know I haven't got any PCB cleaner because I'm out of it at the moment. I haven't had a chance to get some new, but hopefully we can use a bit of isopropyl in a cotton bud and that'll do the same job. Let's see if I can find where what I've done with my cotton buds. We're not having a lot of luck today, are we? Ah, there they are. And of course they're just out of reach, so I've got to disconnect my anti-static strap just to be able to get to them. I am running out of them as well. I'm running out of everything at the moment. Right, let's give this a bit of a clean up. In fact, I think we might just see if we can get a bit of this varnish off with the isoprop. It does seem to be coming off actually, at least around where we're going to be working. Yeah, it does just about dissolve that, so that's not too bad. So we'll dig at that more once we've confirmed this board's actually a viable repair. For now, let's just get enough off that we can actually see them pads. What's that stuck in there? There we are. There we go, that's cleaned up okay. Right, there we go. That's ready for a new 7805 to go in. It just so happens that I have one or two 7805s on hand. So let's pick one of them. Right. And we'll get the heatsink. And we won't go mad with it, but we'll put a tiny bit of thermal grease on the back. You don't need too much. A little bit like that's enough. If you put too much on it, it just squidges out everywhere, and it's horrible stuff when it goes everywhere. It gets on your clothes, gets on your carpet, and it's not pleasant. Right, let's get the nut and bolt out. There's the nut. What's I done with the bolt? I should have put it in here. Yeah, I did, it's there. There we go, got it. And what we're going to do is we're going to stick that through there. I'm going to put that in place on the board. We'll stick a 7805 through the holes. We'll figure out where it needs to go roughly on the board, and then we can bend the legs appropriately with some pliers. Just about there, like that. I've got thermal grease on my fingers. There we go. Just get that to go in its hole, like that. There we go, that's lined up nicely. We'll put the nut on the back. Let's see if we can get this nut to... There's the only problem with having this locking compound on it. It's a pain to... there we go. Got it to go back in. Let's just line up that heatsink because it's a bit on the skew. We'll get the... We don't want to do it up too tight, but we'll make sure it's not going to come free. There we go. Need them in a minute. So now it's mounted to the board. The holes are at the legs are through the holes. Just push them through a little bit more, just so we've got enough to solder to, just like that. And I always prefer to mount it like that, so I actually mount it to the board, do the mechanical fixing first and then solder it in place. Otherwise you're straining against the solder points as you bend it into shape, and you can risk breaking a solder joint. It's much better to do it this way. Let's get them soldered into place. It's the first one. The second one. Come on. A bit more thermal mass needed here really, because it's like a ground plane. There we go. That got it in the end. There we are. So that's the 7805 replaced. Just give the board a quick, my SD mat a quick clean off. And right, let's have another take at that and see whether we've got them voltages a bit closer and a bit happier to 5 volts. Let's clip that on there. I'll plug the power supply back in. Let's get this and switch on there. Well, that's already switched on there. Let's just see what we've got there. About 13 volts. That's adequate. That's okay. Let's see what we've got here. Yeah, that's more like it. Yeah, we've got about 11 volts going into the 7805, and let's see what we've got coming out of the 7805. Oh, we've still got 6. That's not good. So why have we got 6 volts coming out of 7805? Let's see what we've got. Some of these ICs we've got on here. Yeah, that's way too high. That's far too high. So why have we got more voltage coming out of that 7805 than we should have? That's what we need to. That's what we need to investigate. That's a bit weird. I'm tempted actually to. I don't know whether the output's actually soldered very well there either. That's definitely not good. We should not be getting more than like 5.2 volts really coming out of the 7805. And that's a brand new one we've just put in there. And our input voltage to it's fine, about 12 volts is okay. That's a bit of an odd one. I wonder, we couldn't have 2 Duff 7805s, could we? I'm tempted actually just to lift the output on there and just measure what the output is lifted up like that. I think we're going to do that actually. I'm going to lift the output off that IC. That regulator, and see what it is floating. It should be 5 volts, but what could be creating the extra voltage unless there's something leaking somewhere, there's a shorted cap or something. Let's see if we can lift that leg out. Oops. It's going to be awkward now. Oops, there we go, that's freed it. I think we've got it. There we go, that's out. Let's measure what the output on that is. Get this back up. switch on. Let's have a look here. Yes, we've got about 13 volts there. 12.5 volts there. We may have it may just be a coincidence and we've just got another bad 7805 here, because that one again is showing 6.4 volts. That's not right. But let's try a different meter. I mean, this meter is usually reliable. Let's make sure that's switched off for now. This meter is usually reliable. I've used it for quite a long time, but logic dictates that really, you know, a brand new voltage reg like that shouldn't be faulty in exactly the same way as the one you've just suspected to be faulty. So let's go with the other option. I've got another meter here. If you, I'll zoom you up onto it so you can see what this one's actually showing. We'll switch this on. We'll want voltage, out's DC. We'll set it to 10 volts. No, yeah, we'll set it to 10 volts. We'll go on the common there. And let's see what this one is going to tell us. I'm just going to go straight onto the output of it and we'll see what it actually says. Not saying absolutely nothing. Why is that saying nothing? Is it misbehaving? One of the reasons I did stop using this meter is because some of the, well, not use it as much as some of the buttons are starting to get a bit tired on it. In fact, let's go up to the 100 range. That's out, so that's okay. And let's measure the out the fuse and see what that tells us. Oh, there. So we've got the fuse. We've got 12.1 volts there. So let's try. We'll go on the input side of the 7805. Oops. That's showing nothing. We've got 12 volts on that side of the fuse. We've got 10 volts on that side of the fuse. Now we should have about that on this side, on the inputs. Yeah, we've got that. That's on the input side of the 7805. That's looking a lot more sensible actually. And we've got exactly 5 volts on the output of that. So it looks like that's just been erroneous. And my meter's been lying to me. I think we're going to have to stop using that meter for tests like this, because obviously it's not a... Let's go to the 10 volt scale there. Yeah, 5.08 volts. That's absolutely fine. So I will reinstate this. I won't subject to you seeing me shoving this thing back on the board, but I will reinstate that 7805 there, and we'll do some extra checks round on the board. So back very, very shortly. Okay, we're back, and I've got the 7805 reinstated there, and we've now it's connected onto the board. Yeah, we've got a nice steady. It's 5.09 volts it's showing, so that's absolutely fine. In fact, I'm just going to I'll stick you up on the meter. This is where I could really do with another camera, so I could do picture in picture. But so we can have a look at the. There, we've got about 10.8 volts on the input to the 7805 there, and on the output we've got 5.9 volts. So the original one was probably absolutely fine. It was that meter that was throwing us off. But it's good to change the 7805 anyway. It's the part that if I was selling a computer, I'd always put a new one in. Anyway, we'll just do another quick fly around the board. We'll do some basic checks, and then we'll see about perhaps sticking the CPU and the processor in it. I'm just going to go around on the RAM first actually, and we'll see whether we've got any erroneous voltages on the RAM. So most of these probably won't show anything, or they'll show something fluctuating like that. apart from the VCC line, what we're looking for is there's nothing stuck like permanently up at 5 volts. That would indicate there's an issue somewhere. If it's somewhere below there, or it's ground, or the only one we really want to see at 5 volts is the VCC line. These are obviously data lines that show about 2.5 volts, because they're basically, if I put a logic probe on them, you'd see that they're turning on and off very quickly. There's our VCC at 5.08 volts, that's fine. This I think is ground, that's ground. I think these are address lines of ground. There's nothing here that's looking too terrible. I mean, we could be doing this with a scope, a logic analyzer, a logic probe. That's all looking okay. We'll just do the same on the other RAM IC. Again, we're not seeing anything that looks like it's particularly stuck. They all seem to be. VCC, yeah. That should be ground. And this looks quite healthy. Yeah, because things are at various high states, low states, or they're switching rapidly between high and low. So I can't see anything of an issue there. We'll try the CPU socket. We'll just see what we've got on there, so make sure nothing looks too erroneous. There's our VCC, that's fine. That will be, I've got a printout of what everything should be here. Now which way around have we got the chip? That way around, so that should be RW. Not sure about that. That does seem to be going a bit high there. It seems to be peaking up at about 6 volts. I may check on the working +4 on that pin and just compare it before I indeed stick a processor in here. Nothing there. Again, we'll see on the other board that I've got whether that is indeed normal. All these look okay. We're just we're on the data lines at the moment. I'm just literally just going through them all, just seeing if there's nothing that looks particularly erroneous on there. Just concerns me that a few seem to be creeping right up like that, you know, 5 point something volts. I'm not sure where that extra voltage is coming from. Something is getting very hot under my hand as well. Just there again, 6 point something we're getting on there. It could just be that it's a very, very fast switching signal, and that's what's just tricking the meter. But we should be able to tell that if we, yeah, something is getting red hot on here. I won't say red hot. Perhaps that's, but then 2 ROMs on the board just to point you down. As I'm doing this, I just felt them 2 ROMs because I had my hand basically resting on them like that as I was probing the CPU socket, and they are they're not getting red hot, but they are actually getting quite warm. Anyway, we'll carry on along as we was doing. I'll show you what I was doing. I think we were down to about here. Yeah. Nothing on there is looking, apart from, like I said, there's a few pins at the top there, which I am going to have a look on the Plus4, the working Plus4 we've got, and see if they've got similar kind of voltages showing. Like I said, it could just be that they're very rapidly switching signals, and it's throwing this really old analog meter off. But we'll have a quick look on the, again, we've got VCC. It's the VCC I was more worried about, especially when I saw that 6 volts, but obviously, like I said, it was an iffy meter, that, more than anything else. So I'm just going to pause you while I dig my Plus4 back out, and I'm just going to take a few, basically just do the same voltage checks there, and I'll be right back. Okay, as you can see, I've got the Plus4 out and I've got it powered up. Obviously the power supply is somewhat different in this, because it provides its 5 volts from a PSU like the Commodore 64 and other Commodore products do. But we can test on this fuse, and we should have around 5 volts on this fuse here, and if we check there, yeah, we've got just over 5 volts coming in on that fuse. So we can actually do as we said before, and we can test the processor. So if I take you back up onto the meter, there you go, you can see the meter there. If I go onto the VCC pin of the CPU, you can see we've got a nice steady 5.07 volts there. Now the next pin was, when we was testing on that C16 board, was the pin that was floating all over the place, and like I said, we were getting things where it was flashing up as like 6 volts, 6 point something volts. So if we probe that pin on the Commodore Plus4, this is pin 2 on the CPU, we'll see on this it is dead stable at like showing 4 volts. In fact, if we go along, we will see, and we'll just make sure there's nothing on this running CPU. I've got to be incredibly careful while I'm doing this, because I don't want to risk shorting anything, but that is looking quite healthy, quite what I'd expect really. We've not got any of them voltages showing on the meter jumping right up, and it could just be that it was a frequency thing. It could be that there's no CPU in there. So what we're going to do next, once I've just gone across here, is I'm actually going to pull this CPU out of the Plus4, and I'm going to measure the Plus4 board without a CPU in, and then compare that with that C16 board. Right, there, I'm quite happy with that, so I'm going to switch this, let's get you back down there. I'm going to switch the Plus4 board off, and I'm going to take the CPU out of it. Hopefully this should come out okay. There we go, that's the, in fact, let's get something we can put that on. I'm not happy just sitting that on the table, it's too precious. I bet people are thinking there's something wrong when we see how precious I am with these chips, but they really are that hard to get now, and they are that expensive to get now. Let's stick that down there, put that out of harm's way, and we can just do that same check just basically on the socket pins there. So we'll switch back on. In fact, I'll take you back up onto the meter so you can see what the actual meter is showing. So we'll go onto the VCC here. There we go, we've got the 5.8 volts. Now let's see what we get when we go on the next pin there. Ah, now, without the CPU in, that seems to be jumping all over the place like it was on the C16. It's not stable. So I wonder if that's just an indication when you've no CPU in there. Anyway, I'm going to carry on just doing a few tests, basically exactly the same type of things, just ascertain basically I'm absolutely happy with that C16 board, that there's nothing there, like I said, that I would consider is going to possibly kill the CPU, and then we will actually go and we'll plug the CPU and the TED in, and we'll see if we can actually get something on screen, and we'll take it from there. So I'll be back in very, very shortly, in 1 second. Okay, there's the board back in. I have just had a bit of a probe round basically on the TED there as well. I had to just use a bit of wire and stick it in each pin and just measure the voltage, and it's pretty much the same thing. There's a few things that jump around, but there's nothing that looks particularly erroneous on there. There's nothing like stuck up at 5 volts that should be a data pin or anything like that, and that's really what I was looking for. So I am going to put the CPU and the TED in this board. We'll connect it up to a video output. We'll apply some power to it, and we'll actually see if the board does indeed do anything. And that's probably the end of this video for this one, because it is already getting quite a long video. But let's see how far we can go. So that's the CPU in place. Let's take the TED. Straighten that. We'll put the TED in. There we go. Take that out of the way. We've got a video which is compatible. This is I actually found out that the original Commodore 64 and the Atari standard are basically the same. So a C64 and an Atari lead, you should. That one's video. It should work. So let's plug this. This is wired for Atari, but like I said, it should work on a Commodore 60, on a C16, C64, 128, anything like that, to get your composite out of it. If it'll go in the hole. Ah, yeah, there it is. Not a very good fit, that, I must admit. No, I don't like that fit. It doesn't fit very well. I think we'll go back to what we was using last time. At least it gets us at least that way it gets us video out of it. That really isn't a very nice fit on there. That in there, so that's our power in. We'll make sure that's off and plug the power in. We'll we'll leave the leads there. In fact, I'm going to leave that ground lead clipped on, because I want to do some probing and actually make sure that the voltages are alright as it's actually powered up. And we'll get you onto the screen so you can see the screen. Where's my remote? That's AV, that should be it. Right, and let's switch on and see if we actually get anything on it. So let's apply some power. Well, it did something anyway. We seem to have some sort of video signal there, because I can see it in the background. But let's switch off. Let's just check some voltages. So we'll try VCC pin on the CPU here. We'll try switching on, and we'll just see what we've got there. We've got our 5.8. Let's try that next pin across. Oh dear, that's showing. That doesn't look healthy at all. I hope we haven't killed anything. But that was showing like 8 volts then. That should not be right. Let us let's pull that CPU out. Something didn't look happy there. hope we've not fried this CPU. Let's take this TED out. I just want to try them in the Plus4 board again. Put that to one side. In fact, we'll slide that up there a bit. Let's get the Plus4 board. Where's it gone? There it's gone. And we'll put the TED and the CPU back in this board. Just make sure that they are actually okay. Ah, that's not good. That could have something to do with some of it, unfortunately. I mean, it is fixable, thank God, but we've actually lost it. I didn't notice that when I pulled it out. We can spot that we've actually lost a pin off the TED. Let me get another TED. I can fix that, fortunately. There's plenty of pin there to attach it with. I've got the bit of broken off leg there. Let me get one of my other TED chips. I have got some tested TEDs in here. It could just be that that's why it weren't powering up then. Just that, don't like the way that voltage was showing on there, but it could just be, like I said, it's the meter's getting confused because it'll be a rapidly switching signal rather than actually a voltage. So that could be what's just confusing the meter, and there's nothing really wrong there at all. Just slightly bent pin here, so I can straighten that. Just excuse my head getting in the way while I get this. There we are. Get that lined up. Okay, so we've got a TED and a CPU in there. Let's put some video on it. The video is that one. Get the Plus4 PSU. Connect that up and hopefully something will come up on the screen. It's powered up. That's not right though. Hopefully that's just the monitor being awkward. No, that's not good. Try one more time. Ah, no, we've definitely got an issue. I wonder if that TED's not as happy as I thought it was. Let's try one more time. We could have a faulty TED there, unfortunately. Let's try another one. And that's the problem with these, they just seem to die for fun. Ah, no. There may not be anything wrong with it. A pin has got bent under. Something you have to be so careful with. You think you've got every pin straight, and no, you haven't. You've got one that's, it looks like it's gone in. In fact, there was two. They look like they'd gone in, and they'd actually got bent. So let's straighten them pins, make sure they're all nice and straight. Let's try again. Right, that's back in. Let's give that another go. There we go, that's better. So we didn't damage anything. I'm just really concerned about that that voltage on the CPU, the way it was jumping around. It could have been the fact that the TED wasn't. It's not there when you connect it into this board. That's what concerns me. It's not there at all when you connect it to this board. We've got 5.7 volts, and it's the next pin. It's RW, and it's always steady here at around the 4 volts mark. But when I put it on the C16 board, it seemed to jump really high, you know, like up to 8 volts or so. But we didn't have the TED functioning. Right, let's take this non-working TED out. That's a relief. I thought I might have a dead TED then, but obviously no, I've not. We will have to put a new leg on that one that's got one broken off though. In fact, let's use the proper tools for doing this. You're still staring up at a screen, aren't you? Let me just bring you down so you can see what I'm doing. I'm going to, I may be being slightly foolhardy, but I'm going to attempt to put them back in this again and just have it one last try before we look and we see whether there is a definite other issue with this board. Now I've got that right. No, I nearly put the CPU in the wrong way around then. That would have been a disaster. You know, I couldn't do that with a Specky where it would be a Z80 and it wouldn't matter. I have to do it with this where it's basically the parts are irreplaceable. Just make sure them legs are straight. Go around that, make sure that they're all actually sat where they should go before we push it home. Right, let's go for another try. Let's put video in. Make sure that's switched off. We'll connect the ground so we can have a look at some voltages again. We'll put the power up it. We could probably actually go back to the proper C16 power supply because I'm sure that wasn't an issue. Like I say, it was that meter that was throwing us off to start with. But right, let's. I'll bring you back up on the screen and let's see if this does anything this time. Keep your fingers crossed. Let's see what we get. No, it seems exactly the same, unfortunately. I'm just going to quickly probe them pins and see what we've got. So our VCC is fine. We'll go on to, that looks a lot more like it should do. It's staying around the 5 there, but it was like 4 on the other board. But as you can see, we've got nothing nothing booting up on screen. We could have a bad ROM. That is a possibility. I wonder if one of the ROMs has gone bad. We've got plenty of ROMs we could try. Let's get one of the other scrap C16s. And let's try, just as a bit of an experiment, let's just try perhaps swapping one of these. I think they're both the ROM chips. I don't know whether it's upper and lower or what. But I've got exactly the right parts here on this other well, let's try this top one. Let's whip him out. No scientific method about this whatsoever. I'm just we could probably try swapping these between, I don't know if we could swap these between this and the Plus4 with it being that's got all the inbuilt software. I'm not sure how the ROMs actually work in that respect, but let's try swapping these over. We'll try swapping that one first. See if that's made any difference. Well, that seems even deader than it did before. Oh no. No, it's exactly the same. I don't think that's the issue. Black screen. Let's try the other one. Let's stick this in. So basically, all I've done is I've swapped them two ICs there, which I think are the ROMs, or at least one's probably the basic and one's probably the system ROM. I've swapped them from that other board. Again, we don't know if that board works. We'll just see if that's made any difference. Not that I was expecting it to, and no. I think we can definitely say that the TED's working, because it is actually generating video. You can see the lines down the screen there, and it changes to just a blank screen when you switch the power off. I'm suspecting the processor is indeed running, but there is definitely something else amiss. I need to find out whether that socket, basically, I need to find out now whether that socket there should indeed have something in it. None of the boards that I've got have. I'm pretty sure it shouldn't. It's just a spare socket for in-house upgrades and things like that, but I can't be 100% sure. We could say have a fault with, I don't think we've probably got a RAM fault. We could have a RAM fault. That can cause a black screen on these things. So it is a possibility that we've got a dodgy RAM. It's not what I jump out at me straight away. Again, we could have a fault with some of the like these Boss, what are the 7708. I have a feeling I've had issues with them in the past. There's plenty of other things we need to look at on this board, so at least it's not just a simple yeah, that board works, easy repair. We do actually have something we can get our teeth into and find out what's wrong with it. I'm going to leave it there for now anyway, because this video has already dragged on far too long. So in what will be part 3, we will look into this board and we will actually see if we can figure out what's wrong with it and actually get it to do something. So I'm going to leave it there for now. Hope you enjoyed that little update. So thanks for watching, and goodbye.